Hello, alright? You know me. I'm the Earth. I don't mean to moan, but some of you think you can just walk all over me. No, hold on. You do walk on me. What I'm trying to say is, I've looked after you little guys for yonks. Don't get me wrong. I love having you around. You can stay as long as you want. You can use all of my stuff. Well, not all of it. Save a little bit for me. I don't want to run out. I don't mind you using my oil. What's mine is yours. But do you have to drive to the shops to get a pint of milk in a big 4x4 thing?
Watch it, mate.
Chop down trees for paper and stuff. No problem. But why not replace what you've taken so it's there for somebody else to use? Cheers. It's okay to fish in my oceans, but you can see when the stocks are low. So why not chill out? And give Place a chance. Place. Don't get me wrong, you're all still my mates. It's just... sometimes I feel like I'm being treated like a toilet. I know it's not all of you.
No. No, exactamente.
No.
Muchos lugares, ¿no?
También el sol, el aire.
Nuclear.
Eólica,
Petróleo y
hidráulica.
nuclear son los principales.
Fossil fuels provide energy for production and transportation of virtually every product we own or consume. And many of those products are actually made from petroleum. To get an idea of how deeply embedded fossil fuels are in our everyday products, let's take the example of a nylon shirt. Nylon itself is made from crude oil. An enormous amount of energy is used throughout the process of creating the shirt, almost all of it fossil fuel energy. First, the crude oil is extracted from the ground. Then it is shipped to a refinery where it is distilled into chemicals that make nylon. The polymers are shipped to a factory to create the nylon thread. The thread is then shipped overseas where using machinery and labor the shirt is made. Then it is shipped back to North America and trucked to a store. The consumer drives a car to the store, buys the shirt, and drives back home. The shirt is not only made of oil, it's awash in oil. A similar trail of energy use can be followed for nearly every product we consume.
Oil is the most important source of energy in the world today. It provides about 40% of the world's energy supply, far more than any other source.
La energía renovable pues la que puedes volver a utilizar, supongo, ¿no? Que ya se haya gastado de alguna forma la utilizas.
For example, energy from sun, energy from wind tides, energy from like biofuels, but that's not really renewable.
Sí, pues es la energía que proviene de fuentes naturales, ¿no? Agua, aire, sol.
The watermills and windmills of our grandparents produced mechanical energy from renewable sources. Their modern versions produce electricity. Thus, windmills transform wind into electricity. The European production of wind electricity, which has made great progress, is now equivalent, for example, to the combined electricity needs of Denmark and Hungary. Hydraulic energy produces electricity. Small hydraulic plants or big dams, the production process is the same. The energy potential of a head of water is converted into electric energy. Geothermal energy uses heat from the depths of the earth to produce heat or electricity. At just a few meters below the surface, already heat pumps can extract heat from gardens to heat houses. This is a relatively new but promising application. Solar energy can produce heat or electricity. Solar heat panels installed on a roof can cover most of the hot water needs for sanitary purposes and can serve as a backup for domestic heating. It's estimated that over 20 million square meters of solar heat panels were installed throughout Europe in 2006, and not only in the southern countries, far from it. Solar energy is also converted into electricity in solar mirror plants, or directly using panels of photovoltaic cells grouped together in plants or placed on facades of buildings or roofs, or in isolated sites. Biomass is produced from vegetable, animal or urban waste. It's called the sleeping giant because it's probably the most important renewable energy of the future. It has multiple applications. The most widespread is combustion of wood or wood pellets for domestic heating. In industry or in towns, the aim is to co-generate heat and electricity, which offers a much better overall yield. Biogas is produced by fermentation of waste such as liquid manure used in farming or other organic waste. It produces heat and electricity. Purified biogas can be used as gaseous biofuel. Biomass also makes it possible to produce liquid biofuels, biodiesel and bioethanol.
Machines hooked up, which makes us the largest human power plant in the world, is what they say. When a student works out for a half an hour, they can generate enough electricity to run their laptop for 3 hours. So persons on this machine, they're generating heat going into this unit right here. But it then goes into this wiring right here. As you can see, it's not a whole lot of wiring or anything. And that goes into our system. We turn it into DC. It comes over here to the inverter, which is this machine right here. That inverter changes it into the AC current, like we're talking about.
Every time we take a step, we leave energy behind. What if we could capture this energy as a clean source of electricity? Dutch architects Dol are developing the technology to capture the energy of dancers like these, then using it to power the club's music and lights. Certain materials produce electricity when squeezed. This is known as the piezo effect. So a dance floor can become one big generator, turning every movement into new power. In fact, any vibrations we make can generate electricity. Even the rattle of the tram taking you home at the end of the night.
and we wanted to use the energy of the people to power the club. The lights on the dance floor are powered by the energy of the people dancing on it. And what we would do with the dance floor is we translate the vertical movement internally by using a small generator into electricity. Well, people, when they step on the dance floor, they see an immediate reaction. So they know that if they give some energy, they get something back. And that's either something visual in the tiles themselves or something combined when they look at the energy meter. So people are challenged to get a reaction from the floor. And the more reaction they get, the wilder they get.